What do you think design teams need to have in their minds from the get-go to make sure that they start off on this right path?
Yeah, in the beginning, right, it's really important to flesh out in that SD phase, are we committed to timber or are we looking at a different avenue? There have been a few projects that we've looked at where we get through 50%, close to 100% DD phase, and the question pops up of, hey, we have the steel building, can we do it in timber, right? They're not really apples to apples comparisons. They're not plug and play, switch them out. Steel grid is unique from a concrete grid, and a timber grid is different than a steel and concrete grid.
You finally got the owner bought in on mass timber. The architect loves it, the concept's approved, and then the DD estimate lands in your inbox, and the number's twice as much as anybody expected. That's where most mass timber projects die. Well, today's guest, Mason Brandt, has seen that firsthand. On one project he was brought into, the budget came back 40% over. His team went back through the structure, rotated panels, cut beams, downsized columns, and eventually got it back into a full timber building at a number that the owner could live with. Mason's the president of Woodcore Engineering out of Lancaster, Pennsylvania, and he has experience on over 25 mass timber projects. And on more than one of them, he's been the person who kept timber on the table when the budget said otherwise. Here's what we get into today. First, why timber has to be decided in SD, not DD. Timber, steel, and concrete all have fundamentally different structural grids. By the time you're well into DD, switching isn't a design decision anymore. It's a complete redesign, and somebody's paying for it. Second, why species selection can blow up a project that's already been designed. Not everything in the NDS supplement is commercially available, and unlike steel, you can't always get competitive bids on mass timber. The wrong species choice can leave you with a very short list of manufacturers and no leverage on price. And last, why getting a timber specialist into the room before DD is the single biggest thing that you can do to protect your schedule and your budget. Mason breaks down design assist versus delegated design, what each one covers, what each one costs you, and why the fabricator needs a seat at the table very early in the process. If you're working on mass timber, designing it, engineering it, building it, this one's for you. As Mason puts it, clarity is kindness. Get the right people in the room early, and a lot of those expensive surprises just don't happen. So with that, let's get into it.
I'm Mason Brandt, president of Woodcore Engineering. We are a specialty engineering firm based out of Lancaster, Pennsylvania. My background spans a good range of structural engineering consulting, working in a variety of projects, wood, concrete, steel, from mid-rise construction to infrastructure projects, rehabilitations, existing facility reviews, kind of a good mix of structural engineering, generalist kind of things. And about January of 2023, I had the opportunity to join Quality Buildings, timber frame and wood frame contractor in Lancaster, Pennsylvania, start in a structural engineering department for Quality Buildings. And then in July of 2025, we took that engineering department and spun it off into its own standalone entity called Woodcore Engineering. Our focus is wood and timber engineering design, focus on constructibility, getting it right from the start. What I tell my team is, when you see by others on the drawings, that's us. Our goal is to make things happen in construction, get things built between construction means and methods, delegated designs, specialty timber engineering. We can even serve as the EOR if it makes a good fit for the project. And other things about me, I've been a volunteer firefighter and a part-time career firefighter for a little over 20 years now, outside of Lancaster, PA. And with that, right, I get a different perspective than a lot of other engineers, designers on the design end, where we have to deal with the buildings and built environment when natural disaster strikes, during fires and other emergencies, right? The different challenges that not many other design professionals have to think about on the tail end of these projects, right? So as part of that, with the mix of experience I have, I teach building construction programs to firefighters. So trying to make that bridge happen between the design realm about what's being designed, what's being built, and the people who have to work in those buildings under not so great situations.
Yeah, no, I appreciate that background. How many mass timber projects have you and the team worked on?
Oh, let's see. We're probably north of 25 at this point,
All right.
either in the construction piece or in the design phase. Right, we're north of 20, I think.
Got it. So you guys have had dozens of projects kind of like run through, and I think that's what we're going to unpack a little bit today. Is like, what have you guys learned through those projects, specifically on the engineering side, that really like makes them successful or not, right? And like what to watch out for, what to make sure that we're doing right. Just kind of like that checklist of do's and don'ts. And so I think the first question we're going to start off with is like, when it comes from moving a mass timber project, from concept to design to construction, we're talking about doing it precisely and with cost control to make sure it gets done successfully. So what are some of the high level key things that you think are important to get right with mass timber?
High level key things. We have to find a good partner that fits the project, get a good team together, and have the project designed with consciousness of all phases, right? Not just to get the material bid correctly, but through a production facility and then out to the field, right? These are finished pieces, finished elements. Things have to go together. There's not a lot of opportunity for field modification. So we have to get it right before it hits fabrication, or we're going to have some interesting challenges out in the field, right? And field delays can kill project timelines, kill project schedules, and burst the budget.
And so what do you think, if we started at the beginning, where do you think the difference between mass timber, steel, concrete, whatever your building is going to be made out of, like, what do you think design teams need to have in their minds from the get-go to make sure that they start off on this right path?
Yeah, in the beginning, right, it's really important to flesh out in that SD phase, are we committed to timber or are we looking at a different avenue? There have been a few projects that we've looked at where we get through 50%, close to 100% DD phase, and the question pops up of, hey, we have the steel building, can we do it in timber? Right? They're not really apples to apples comparisons. They're not plug and play, switch them out. Steel grid is unique from a concrete grid, right? And a timber grid is different than a steel and concrete grid. So if we're entertaining the idea of timber, it's important we flesh that out well before we get to DDs, well before we get to CDs. If we have to try to make a timber project go with a steel grid and we can't compromise on the building program, we build in a lot of inefficiencies and the timber becomes really, really expensive. It's not a case we can't do it, but in those cases where we're trying to make timber perform like steel, that's where we see these timber projects cost well in excess of what they could.
What if somebody what if they're not committed to timber, but they're like, hey, I want to keep this as an option? What do you tell people to do that?
I'd say if you want to keep it as an option, it doesn't have to be all or nothing, right? We have plenty of case studies where we see a lot of complementary materials used. You might see a steel frame with CLT decks. You might see some accent walls, some glulam arches. It doesn't have to be all or nothing, right? Timber, it takes a lot of coordination, but timber does play well with steel. It does play well with concrete and masonry. It just takes some intentionality and some detailing.
Got it. And if we're talking about, initial steps when we're setting out, like, hey, we're going to be either committed to timber or keeping those things in mind that you talked about so that it's not impossible to go timber. Where are you generally bringing in like the timber expert here, and like, who is that timber expert to make sure that these things are going right?
Yeah. If we're down that road, a great place to bring in someone as a design, like a good example is design assist, right? If the design team, if their first few timber projects, right, they're not super confident, or they might want a second opinion on how to really execute this well, a great way is to bring someone in that was especially focused in a design assist effort, where they can advise and consult the design team, the owner's rep, with real-time price comparisons, right? If we're making decisions that affect the size, the volume of timber, getting some real-time price feedback in a design assist effort is a good way to help manage potential cost increases, add some cost containment and some certainty to the project.
And so when you're bringing in this person, like, what are the things, because you are that person in this case, or at least you can be, right? What are conversations that you're having with members on the project team about like the nuances, the details, like when we're talking about accessing cost or making sure that we have cost containment, like what specifically are we looking at?
Yeah, big question there is, what kind of material are you looking to use? Are we talking a European product, North American product, Southern pine, Doug fir? Those kind of questions really matter in a timber project compared to a steel project, right? And I give the example, when you do a structural steel project, say you pick a W8x10 steel beam A992, that's something that a structural engineer can put on a drawing. When it goes out to bid, you can get competitive bids. Most people, most steel manufacturers, fabricators, and erectors can source that pretty easily. There's a built-up network, and it's apples to apples comparison. You can get competitive bids for that. When we compare that to timber, not every material has 5 or 6 different manufacturers that are local enough to the project to competitive bid it. And even when we look at those available product grades, there's a document out there called the NDS supplement, for those who aren't familiar with the structural engineering aspect of it, right? And that gives a list of glulam materials, grades, layups with different material properties and strengths based on the wood species. Not every glulam in that document is readily accessible to the marketplace. And even say if you look at 3 different southern pine manufacturers, one might make a 20F grade material, another one might make a 24F grade material. And even in that, they have different layups combinations based on how you want to use that beam or column. So to really get an apples to apples comparison, those 2 materials have different strength capacities. And with wood, the strength, a lot of cases, is based on the area of the timber, right? So if you're in that position where you're comparing a glulam manufacturer that makes a 24F material versus a 20F material, that 20F material might be a little more cost competitive in a dollars per cubic foot scenario, right? But you compare that to the 24F, we have a higher grade material, you might need less timber volume to achieve the same structural capacity, right? So if our dimensions are fixed, if we're contained at a certain point with a maximum column size or a maximum beam depth, we might not get a competitive analysis between these 2 manufacturers. We might be stuck going down one road that might not be in the best interest of the project, right?
Okay, got it. And so like when you're talking to the architects here and you're going through all this kind of stuff with that, like what does that mean in terms of like the way that they're actually designing this building? What do they have to keep in mind to adjust for these nuances that can like keep that cost, keep that variability, keep that choice open that you just talked about?
We have to keep those, the high level, big picture items in mind, right? Is there a certain area we want to focus on? A showcase area, a showcase piece, right? Floor to floor heights. That's a critical dimension area we need to be concerned with. Allowable areas of the structure. Those pieces of information, as we adjust the timber size, adjust the beam spacing, and evaluate the different structural materials that are available. Right, you might have a project where the architect loves the look of Doug fir, but it's on the East Coast. We have to ship that finished product from the West Coast in a lot of cases, right? So those shipping costs offset might switch us into a European product or a Southern pine product, right? It's the combination. It's a, what do they call it? Archistructural is the right term for a lot of these timber elements. It's a visual finished structural element. So it's not just how does the material perform that impacts what we want to use and how we want to spec it.
Okay. You talked a little bit about, like supply chain sourcing, like if you got an East Coast project, but you want West Coast Doug fir, all that kind of stuff. Like, how do you walk through, outside of like visually, what you're looking for? Like, how do you walk through like choosing quote unquote, like the right species, or the right supplier, if you will? Like what do you consider and what do you bring to the team and say, hey, here's the options, here's the pros and cons on like regional sourcing, et cetera?
That's a great question because it's not always the closest geographic manufacturer that could have the best package for the project, right? We have Canadian vendors, we have U.S. domestic vendors. There's a very well-established supply chain that comes from Europe, and we're also seeing newer manufacturers coming on board all across the globe. Woodworks has a great resource that can give insights to different manufacturers that are coming online, what they offer, where these projects are happening, right? A key piece is trying to understand what the client wants to look at for the project. We looked at one in the central Pennsylvania region where they were back and forth between a European spruce project or a European spruce versus a Doug fir versus a southern pine. And that one, the architect and the interior designer had two very different approaches to how they wanted to use the space. The architect wanted to highlight the color of the material, whether it was Doug fir or southern pine, to bring warmth, or to really highlight the material itself in the space. And the interior designer wanted more of a like a Canadian spruce or a European spruce product, which is more of a neutral background, so they could highlight other aspects inside the space. Right. So that's at a high level where we want to start. Most timber projects we look at, especially in the U.S., the case studies are coming from the Pacific Northwest. They're in Doug fir, because Doug fir is local to the Pacific Northwest. Supply chain is very well established out in Washington, Oregon. So we have a lot of the conversations where an architect, if it's their second or third timber project, all they know in reference is what Doug fir looks like. So we try to give them other options as to, hey, if you're looking at a project on the East Coast, here are some equivalent structural performing products that might be a little easier to source, might cost a little less money. But if you want Doug fir, that's still a viable resource, a viable option.
What about the economic factors? Because when you and I were chatting before we hit this podcast, you talked about like Buy America funding, et cetera. Like how do those factors play into this decision?
Yeah, that's something that has come up as a headache for us a few times now, where not all the funding for these projects is always fleshed out when we start down the design road of picking a species. When we get up into New England, we've looked at two projects now where they were initially specified as a Canadian product. So the design team went through a full design, issued construction drawings based on Canadian product properties. And once the project went out to bid, the owner got some Buy America funding. And as a caveat to that, you had to use U.S. domestic source products. So it didn't fully eliminate spruce, but now we had to pivot and propose alternate materials in the southern pine that would work for the structural performance. And in some cases, we had to do some redesign work on resizing beams, resizing panels to validate that the southern pine product met the structural demands that the Canadian spruce product looked for before. So those things do come up as we go through projects. We want to finalize funding. There are a lot of projects that once they get beyond the design team, funding sources change. So that's a pain point that we've had to navigate a couple times now, switching out materials. And then also when you change from a Canadian spruce to a southern pine, we go from that neutral background material to something that's a little more yellow, right? So does the owner buy into that new look, or do we need to do something to the material to alter the look of material, right? All things that come up as pain points.
So I guess let's talk a little bit about like scope of engagement. Like when you're working with different partners, like talk to me about the difference between design assist and delegated design in this context, and like what you can and can't do in each group, and like maybe where you'd recommend people lean into.
That's a great question, Brady. Design assist is a great avenue for an engineering team like us to come in and support an established design team and an owner's rep, give them real-time information on how different changes to the design, sizing of members, species affect the dollars and cents, right? And we can give real-time feedback as to, hey, if you want to use a bunch of exposed steel hardware for your connections, this is the price impact compared to, can we adjust the timber sizes a little bit, maybe reduce the steel. If we're looking at the grid of the building is another good example. Right. If we can adjust the grid in some cases, either move column lines, shrink column lines, adjust beam spacing, optimize for a CLT panel, reduce some glue lam in some cases, right? Those have real dollars and cents impacts that we can give real-time feedback on. And we can help the design team navigate a few things. We're looking at a project in New Jersey right now that has some impact with tidal water coming through, and how does that impact the timber material that the water might be exposed to? What treatment options are out there? How do we find a good product and a good timber product that will give the building longevity and hold up to those elements? Right. Those are some real-time feedback pieces we can give to the design team. With Design Assist, though, our team would not be responsible for providing a PE seal on anything we do, right? We provide information for the engineer record to review, analyze, and the EOR is still responsible for developing those drawings and putting their seal to the project. We contrast that to delegated design. Delegated design, the design team lists out specific elements that the contractor or subcontractor is responsible for providing a design for. A lot of times that evolves into connections. So you might have different timber manufacturers that have different flavors in how they want to do their connections. Some lean a little more heavy on steel. Some want to use a little more wood to wood connection, right? So a good approach, if we don't have a specific vendor on board early in the design phase, is to delegate those connections out, right? The EOR still provides the performance criteria, the loads, and other information for the manufacturer to design those connections to. And they still have the opportunity to review that, but we have a second set of eyes on the project in a delegated design scenario. If we are the delegated designer, we would put our PE seal on those calculations, submit them to the engineer record for review and approval, right? It gets a little more collaboration with the manufacturer. It takes some risk off the design team, shifts it to the construction arm of the project. And we have a little more overlay in review, making sure we really meet the connections and the connections are constructible. Sometimes we run into issues where the connections we get on a project, you just can't build it, whether it's sequencing, whether it's availability of product. That case of, a good example is if we have a Buy America project, it goes all the way down to hardware. You still need to source U.S. domestic hardware. And sometimes we get a set of drawings that are detailed for European or overseas hardware vendor, right?
Yep.
So in a delegated design approach, your timber vendor, your specialty engineer you partner with provides that connection detailing for review and approval.
Got it. And so like the projects that you've worked on, do you see any specific path, whether it's one or the other, in terms of like better project outcomes?
Both have their place, right? Both have good pathways to success. The key part in both of those is we have the people that are going to be manufacturing and putting the pieces together have collaboration, buy-in on the process. They have some say before material hits a site on how things are being put together, how they're designed. The design assist realm, we shift a lot of that early on into the project, where as we're working through design considerations, you're incorporating people who are going to be working in the field, putting it together to give feedback on, hey, that sequence is just not going to work well, or here's a more constructible connection. Not that what you're proposing is wrong, but a good example is trying to eliminate a lot of field welding. Field welding with timber is not something we recommend. So if we can shift to connections that are bolted, right? It seems like it's something really simple, but if you're navigating 300 field welded connections on a project compared to something that's bolted, that's just an assembly piece, you have people putting a bolt through a hole, tightening a nut. Those are little things that might have a small impact, but over hundreds of connections, they add up to time, they add up to labor and project savings.
I guess since we're already on the subject of like constructibility and like in the field, what specifically do you do, or do you recommend other people on the team do with the folks that are actually going to assemble this? Because like you guys have a little bit of unique insight, having like the QB side of things, like working hand in hand. Like what have you guys learned on the design side from the guys in the field that you kind of try to fold into standard practice now on your projects?
Yeah, and that's a great perspective we've had, where we get to see some of the pain points from the guys in the field. Now we can incorporate it into some design. A big thing that we see is tolerance, right? Paying attention to tolerances, install sequencing, right? If piece A has to go in before piece B, how do we brace it? How do we support it? There's cases where can you actually get the bolt to fit if you have 2 or 3 beams coming in together on a connection, right? Those are all things that we pay attention to when we're doing delegated design work, when we're doing specialty engineering work, thinking the whole way through the finish line. A lot of times I'm working backwards, right? It might look good on paper. It might look good in a Revit model, but if the guys in the field can't put the pieces together, that's not going to work.
Talk to me, I guess, about some of the more recent projects that you think fully embody like the principles that we're talking here that you've been involved with.
Yeah, so we're working on a train station up in Maine. That was one where we had to do some navigating on material. And then based on that, right, some of the initial designs that were using a Canadian product, once we switched to Southern Pine, the values of the timber have changed. So we need to validate that the glue lam and the panel still work for the loading that's required. The capacity of connections, right? A screw, something as simple as a screw doesn't have the same value in every case. It has the same steel values, but a lot of what goes into a screw capacity is what you're connecting it to. So if you're designing a screw connection for Doug fir, and now you need to switch to a Southern Pine, the connector capacities change. So our patterns might change, our edge distances might change. The look and feel of the connection in some cases with exposed connections are going to change. That project also, we had to navigate. It's very much like, that one is very much like building with Legos. It's a small project with lots of pieces. There's a very specific sequence in which the pieces have to go in place, because we have some cases where a glue lam beam is supported by a CLT wall panel, and those two have to support a floor panel that gets a wall above, right? We're also navigating around steel that's already in place. So how do we get the pieces off the truck, around the railroad, working with the windows at the time we have to work with the railroad, getting them set in place, right? So that project has a lot of field challenges that we've tried to bring back into the design approval phase before we have to navigate those things in the field. We've had some conversations about, we're front loading a lot of these field problems as much as possible. What kind of time savings do we have for the guys in the field if we can figure out the solution back in the office, where if we have the same problem that hits the field, they're job stop problems. You come up with a problem, you have material that might be swinging 20 feet in the air. We have to set it down. We have to reposition. We have to make adjustments, right? How many hours of productivity loss do we have for something that we could have picked up back in the office? That's a constant conversation we have, right? For all of our customers, all of our partners, right? As much as we can pull those field problems back in the office and find solutions ahead of time, that leads to a lot of good outcomes.
Yeah, I bet. And all of that obviously leads to like schedule savings or adherence, costs, all that kind of stuff. Is there any of the projects that you worked on that you can point to and you're like, yep, we did XYZ and it made it fit within the budget where otherwise wouldn't have?
Yeah, so we're looking at a elementary school addition down in the DC area, where initially we came in this project. We gave some initial budget numbers based on some conceptual information, very standard practice, right? You give some initial budgeting, and as a project went from SD phase to DD phase, the project budget almost doubled, right? And a lot of things go to, macroeconomic price swings, but also as we look at that in the beginning, we come up with what our typical timber sizes are, what we can expect. And a lot of the cost is driven by fiber volume, right? With wood projects and timber projects, the cost of material is driven by fiber volume. So when we went from initial look, some of the columns had upsized for the DD phase. We had a lot of beams in the project that were to give a consistent architectural look, right? So our team, once we got that first number back, the client was pretty surprised at what they saw, right? But as a design assist effort, we were able to provide fairly quickly, within a week or two, some suggestions on, hey, can we rotate the panels to span a different direction, cut out some beams, cut out some girders, right? We're reducing fiber. We're also reducing hardware. We're reducing piece count. And the fewer pieces that the timber erector has to install, the faster their install goes, right? Also with the column, if you switch from a 12 by 12, roughly a 12 by 12 to a 10 by 10 column, that's a significant fiber savings. In a lot of cases with columns, we're sizing the columns to meet a certain dimension, maybe for a beam or a girder, not truly for the column's load capacity. So if we can make some adjustments to the column sizes, adjust the beams and girders to match the column sizes, that can translate to a lot of savings in glue lam. And through that process, we were able to bring that number back down about 40% from the high point. right? So it went from a conversation of, hey, timber's way too expensive. We've completely blown the budget here. We need to look at other options. Is there anything we can save and keep in timber? To we brought it back to a full timber structure with a little bit of a price increase from that initial budgeting, but we kept it a timber project, right? And that's the goal. There's been a trend we've seen in the market the last 5-10 years where we get this initial budgeting and then it spikes up, and then that's where a lot of timber projects die. In that DD phase, we switch to steel, we switch to concrete. In addition to some fantastic case studies that Woodworks and some other partners have put together for projects on the East Coast, projects on the West Coast, we're seeing that trend too, where there's this kind of spike in price as the design team fine tunes what the client truly wants in the space, and we can give that real time feedback on how do we fine tune the structure as well and keep it close to budget or within budget.
Are there any like precursor conversations or things that you talk to clients specifically about to like set expectations and like kind of like map the journey in timber about how it might be different than steel and concrete, or like, hey, this might, exactly like you said, like you might get a very high number back first. We can work that backwards from the beginning. Like how do you set and meet expectations with the client?
That's always a goal, right? Is to keep the client expectations with something we can meet. Sometimes we aren't afforded that opportunity though, right? Depending when we get brought into the project, if we're brought in at CDs, it's kind of here's what it is, or we go back to the drawing board kind of conversation. The earlier you bring on a partner, the earlier you bring on an expert, you can get that feedback and help inform your decisions to try to eliminate any of those wild swings through the project. Those things do happen, right? But we're trying to minimize how many twists and turns this project goes and still reach that destination. So if we're involved once the base concept is outlined, we can give some feedback to start with to the engineer record. Hey, here's a timber grade and species where if you need to go out and get competitive bids, you can get decent competitive bids based on designing to this grade, and clearly lay it out in the drawings. What is concrete has to be a minimum performance standard, and what is flexible. That's always a question that comes up, whether it's in design assist or delegated design. If the drawings and documents don't clearly say, hey, what is a definite? What is a minimum? What's a mandatory compared to these things are optional? We're looking for different ways to make this and fine tune this, from the specs to the drawings to the details, right? Clarity is everyone's friend. Clarity is kindness, right? That's a great thing in these projects, where if we can have clarity from the design team, clarity in the documents, on the construction end, that translates well to cost savings and cost containment.
And so if you were sitting on stage, helping the next generation of like timber designers navigate this whole process, maybe they've never even touched a mass timber building, maybe they're working on their first one, like top 3 things that you're going to like leave them and impart with them, what would they be?
Number 1, truly understand the material. Wood and timber are a great resource. It's plentiful, but it doesn't behave the same way the steel and concrete do, right? And a lot of coursework for new designers, new engineers, we focus in school on steel and concrete because that's a preponderance of what structures are built, right? We can take a lot of the same concepts from steel design and apply them to wood. Basic beam behavior is basic beam behavior, but we have to truly understand the material and how the material behaves, because wood, depending which direction the grain is and how you apply forces to it, it behaves very different. Short-term loading, long-term loading, serviceability, all those things are different than steel. Same high-level concepts, but the application's different. And also understanding that pace of when you look in your table of the NDS, not everything that's listed there you can actually get. You can actually even competitively get, right? There might be one manufacturer that makes said glue lam. Another thing really is designing with the end in mind, right? A lot of times we get caught up in the beginning design. You're just trying to get stuff on a piece of paper, get stuff to a point people can bid it. Well, what are they actually bidding to? Right? Have we provided enough information where we can make educated bids, educated decisions on how this building is going to perform, where we need to source from, right? That's a big piece to it too. And then thinking about the field condition, right? Thinking about the people who are actually going to have to put said pieces together. A lot of people that are designing buildings today have never had to swing a hammer. And that's truly a blessing when we do have people that have some field experience that are designing buildings. But not everybody has that opportunity to go out and experience what building a structure is like. Even, working on home projects, we have a lot of people that are great engineers, great designers, but they also don't even work on their homes, right? So designing things with an understanding of how people are actually going to put them together is critical and crucial. There are a lot of great designs that unfortunately can't be built just because we can't make the connections work. The geometry doesn't work. It looks great in a model, great on paper, but things don't line up in the field.
No, that's good advice. And then I would say on the other side of like things to do, do you have like a top list of like, absolutely do not do this?
Let's start with to do. If you have the opportunity, go see construction as it happens. Doesn't matter if it's your project, if it's somebody else's project. Go out as much as you can, get in the field, talk to the guys who are putting things together. Try to understand how things go together. Look at the drawing, and then look at that condition that was actually constructed. That's some of the best learning I've ever done, was being heckled by guys in the field. The first time, I think I was an engineer for 6 months. I got to go to Tennessee to check out a warehouse, and the guys who were doing the framing, they were heckling me about which way I ran the joists in the deck, right? So I think no matter what, I was the engineer that showed up, and they were going to heckle me even if I got it right. But that's crucial, is just if you're a new engineer, new designer, go out and see projects in construction. Things not to do, we'll have to come back to that one.
Well, I'll put words in your mouth based on the conversation. Like, don't stay siloed. Don't not engage with the rest of the team. Don't actively be proactively asking questions, reaching out to people, and don't ignore the differences between wood and steel or concrete or whatever.
Yeah. Those are great ones.
Yeah, those are good. And I'll put a little star and asterisk next to those in the show notes. Make sure those are mine and not yours in case I said something dumb. But this has been great, Mason. I appreciate you kind of like unpacking everything for us from an engineer's perspective. We've been watching some of the projects you guys are doing. I'm excited to see the ones you just talked about kind of come to life. I know potentially we'll have some pictures up here as you're talking so people can see them. If people wanted to learn more about you, how you can help them in this journey, like where can they find you?
Yeah, you can check us out on our website, www.woodcore.com. You can also find us on LinkedIn. And, we're more than happy if you have a project, if you just need some advice to point you in the right direction. We're not lawyers here, right? We're not charging by the minute. There's still that saying where, we're in that environment where all ships rise with the rising tide. The more we can do good projects and execute timber well, the more everyone will benefit, right? It doesn't hurt to ask for help. It doesn't hurt to ask for advice. What we want to avoid is kind of what you alluded to there, Brady, is staying siloed and not asking questions, not validating what we're doing. Because if we do have a few bad projects, people aren't going to say, well, hey, that was a bad design. They might lean toward, hey, timber's not a good option for this. And that might not be true. So yeah, we're more than happy to help. If there's questions, things you want recommendations on, feel free to reach out.
All right. We'll link that down below so people can reach out. Thanks for joining me, Mason. Appreciate you imparting some wisdom, and I'm sure we'll see you around.
Thanks, Brady.